So I really could just rename this video to factoring because by now most of you are pretty comfortable with intercepts. There's not a lot new here, but you're going to have to do some factoring. So we've been talking about long run behavior, what happens at the outside or end behavior. Now we're going to talk about short run behavior, what's happening kind of in the middle. Specifically, this video will talk about intercepts. So short run behavior has to do with intercepts and turning points, which is where the graph changes directions. We already know how to find intercepts. The horizontal intercept is when the vertical, the output is 0. Okay. Horizontal intercepts when output equals 0, and vertical intercepts are where the input equals 0. All right, and these are also called, when the output is 0, the horizontal intercept, those are also called zeros sometimes. They're also called roots sometimes. When it says find the vertical intercept, okay, we know how to do that. Find the roots, remember roots are the horizontal intercept. So the vertical intercept, that's when the input is 0, right? It's when it crosses the vertical axis. That's the word. When the input is 0, so when x equals 0. So we just find what is the function evaluated when the input's 0. Well, we get 0 to the 6th minus 3 times 0 to the 4th plus 2 times 0 squared. I see where this is going. We got a whole lot of zeros here. So the vertical intercept is at 0, 0. So what are the roots? The roots are the horizontal intercepts. When the output is 0. Well, when is f of x equal to 0? Replace the f of x with a 0. And we can solve this by factoring. Something is equal to 0 if any of its factors are equal to 0. So we're going to start factoring this by taking out the greatest common factor. What's the biggest thing that all of these terms share? They don't share any coefficients, but they do all have an x squared inside of them. Right? X to the 6th is x to the 4th times x squared, right? 4x's times each other times 2x's times each other. Now we've got 6x's all multiplied by each other. That's x to the 6th power. When we factor that out, we subtract the exponents because, again, x to the 6th is just x times x times x times x times x times x. Yeah, it is just 4x's times each other, x to the 4th, and 2x's times each other, x squared. Minus 3x squared plus 2. You can check your answer by distributing. Right? If we distribute and multiply all these out, we should get back to where we started. And we need to keep factoring. We need to fully factor this thing. X squared will stay by itself, but we can factor the thing inside the parentheses. It's a trinomial. So we're going to try trinomial. So we're going to try, get it? We're going to try to factor it into two binomials with two terms. The only way this is going to work is if this is an x squared and that's an x squared. That'll give us that x to the 4th. Now we need two numbers that multiply to 2 that add to negative 3. Remember, I have extra factoring help in the module for this section. So multiply to 2 that add, well, if two numbers multiply to a positive number and add to a negative number, they must both be negative. The negative 1 and negative 2 multiply to 2, check. Add to negative 3, check. Let's see if this makes sense. If we check our answer, we FOIL, we get x to the 4th minus 2x squared minus 1x squared. That gives us a minus 3x squared. Good. And the last one's a plus 2. Good. We factored right. We're not done. We can keep factoring. It's the gift that keeps on giving. Nice. So x squared is done. But x squared minus 1 can be factored. It's the difference of squares. A squared minus b squared is a minus b times a plus b. Yeah, I really remember that factoring, how much you love factoring. So this is x squared minus 1 squared. It'll factor at x minus 1, x plus 1. This thing over here, though, that's not a perfect square. 2 is not a perfect square. So that second one can't be factored at all. Okay. Whew. We've done a lot of factoring. What are we trying to find? We're trying to find the roots. When does this equal 0? It equals 0 when each piece is 0. So this is true when the first piece is equal to 0. Well, that's when x is 0. When the second piece equals 0, that's when x is positive 1. When the third piece equals 0, that's when x is negative 1. And when the last piece equals 0. Wait, when is x squared minus 2 equal to 0? Well, that's when x squared is equal to 2. We could add 2 to both sides. And then we can square root both sides. Whenever you square root both sides of an equation, make sure to add that plus or minus, right? Because there are 2 numbers that you can square to get to positive 2. Positive square root of 2 squared gives us 2. Negative square root of 2 squared gives us 2. So plus and minus the square root of 2. There are a lot of roots here. Lots of roots. So here are our roots. These are our roots, or zeros. And here is our vertical intercept, just as we were asked to do. Whew. It's a long problem. It's mostly just all factoring. Let's do 2 more examples. These next 2 are going to be better. Because in number 5, it's already factored. So how do we find the zeros? Well, the zeros are when the output, right? Zeros are the horizontal intercept. Got that up here. Zeros are the horizontal intercepts. That's when the output is 0. That's when 0 is equal to t minus 2 squared, 2t plus 3. And we also need the vertical intercept. That's when the input is 0. Vertical intercept's always going to be much quicker. Not always, but usually. So when is the input 0? When we plug in 0 into our function g. That's going to be 0 minus 2 squared times 0 plus 3. Let's do things one at a time. 0 minus 2 is negative 2. 0 plus 3 is positive 3. Oh, okay, so that's 4 times 3, that's 12. That's our vertical intercept. The input's 0 and the output's 12. And now the zeros aren't that hard. The horizontal intercepts aren't that hard because it's already factored. So this is true when the first piece equals 0. That's when t is positive 2. And when the second piece is equal to 0, what is that? Let's just write it out. The second piece equals 0. Subtract 3 from both sides. 2t is negative 3. Divide both sides by 2. Oh, t is negative 3 halves. So here's our vertical intercept. Here are our zeros. And that's our answers. We can also do this graphically with Desmos. So if we wanted to find the intercepts right here, we could pull up Desmos, plot that function, which I already forgot. I think it had a t cubed somewhere. T cubed plus 4t squared plus t minus 6. Find all the intercepts of that. Okay, well, we've got horizontal intercept, horizontal intercept, horizontal intercept, vertical intercept. The horizontal intercepts are at negative 3, negative 2, and 1. And the vertical intercept was at negative 6. There we go. We did it. That's intercepts. 10 out of 10. Happy face. Let me know if you have any questions and good luck. Bye-bye.